Hi, my name is Annalicia and I'm a junior, and today we're going to be working on factoring and long division with polynomials. So for the first factoring problem, we're going to factor using grouping. So with these two, if you split the equation in half, you have two separate sections that can both have an equal factor taking out of it. So for example, for 5x plus 10, you can take out 5 from both the 5x and the 10 to get 5 times x plus 2. And then on this side, you can take out x squared, 2x squared actually, to get x plus 2. So the goal for when you're factoring by grouping is to get the same number on the inside of the parentheses. So like the same equation, so how both of these are both x plus 2, that's what you want. And then when you're writing the other factor, you are just taking these two numbers and you're putting them together. So then you're doing x squared plus 5 and then x squared plus 2. And this is your final equation. So now we're going to do factoring when a is greater than 1. So here, the coefficient is 3 instead of just 1 peak. So first, you're still going to find what you can multiply to get -5 and add or subtract to get 2 peak. So with 5, there's only one possible multiplication to get 5, so 5 and 1. And then we're going to put it into the equation. So when you have a coefficient that's greater than 1, if it's something like 4, you can split those into like 2x and 2x in the different factors. For example, this would be 2x plus whatever, and then this would also be 2x. But you can multiply those in the end to get a coefficient of 4. So if the coefficient is also factorable and it's necessary for getting the rest for your B and your C, then you can factor that out accordingly. But for this one, 3 can only be factorable by 3 and 1. So when you're putting it into the final factorable equation, it can only be 3 and 1. So when we're going to factor it out, we're going to put 3p minus. So in this case, the 5 would go on this side because you still want it to equal the -2 even when you factor out or multiply on the other side. So this would be -5, and it's minus because this -2 is minus, so the 5 has to be more. And then on the other side, you would have p plus 1 because it still has to be negative because of the -5, but then it also has to be positive. So when it multiplies by the 3, it's positive and this is negative, and it'll get you your -2p. So final answer. So for the next one, it's the same thing. 4 is only factorable out, well, it's factorable out by 2 and 1, but also by 4 and 1, 2 and 2. So 3 is only factorable out by 3 and 1 again. So you know that this is still going to be 3n, and then in order to get it to equal -8, you would still have to multiply by -2, and so the other side would be n minus 2 as well, because this has to be negative, but this still has to be positive, so when these two multiply, it will equal the +4. The reason why it's 2 and 2 and not 4 and 1 is because, like before, when you factor it out, this is going to equal -6n, and then this is going to equal -2n. And when you put those together, it will equal the -8n that is in the equation. So then you would have to use the 2 by 2 instead of the 4 by 1. So when you're factoring it out with a coefficient greater than 1, you have to consider the multiplying by the number and how it gets you to this one. So the answer is this. For the next equation, this is factorable out by 3 and 3 and also 9 and 1. So the 2 is only factorable out by 2 and 1. So when you're putting it into your factor, you're going to have 2n. And then because this is negative, it's going to be a negative and a positive. So you're going to have a positive greater number though, because the b is positive. So we're going to have a -3 on this side,
and then we're going to have a positive 3 on this side. So when you factor it out again, this would equal positive 6n, and this would equal negative 3n, which would get you the positive 3n. And this goes to a positive 3 because, once again, it has to be greater than whatever it's being added or subtracted by in order to get you the positive. And then these still factor out together to get the negative 9. So the final answer? Okay, so the final answer, I tried to do a coefficient that can also be factored. So this can go into 3 and 3, but it can also go into 9 and 1. So when looking at this as well, this can go into 7 and 3 and 21 and 1, but it's less likely it's going to be 21 and 1. So with this equation, because it's a 66, it's likely that it's going to be the 9 and the 1 instead of the 3 and the 3. So when factoring it out, it's going to be 9k. And then these are both positive, so it's likely that the factors are going to be positive as well. So then you're going to put the plus 3 on this side, and then you're going to put the plus 7 on this side. The reason for that is because when you factor it out, the 9k times 7 is going to equal 63k, and then the 3k times k would equal positive 3k, and that gets 66k, which is what's here. And then again, when you factor these out, this gets you the positive 21 that you have right here. So the final equation would be So now we're going to do long division with polynomials. We're going to set up the equation. When you set it up, it's like normal long division. So you have the term that you're dividing on the inside and the term that you're dividing by on the outside. So when we write out the equation, it's just 10x squared plus 19x minus 25. And then on the outside, we're going to put the x plus 3. So when you're trying to figure out what to put and multiply to divide by or subtract, you're trying to get the first term with using your equation. And it has to be able to fit into your term. So for instance, if this was a 2 or an x to the third, you wouldn't be able to do anything because you can't multiply anything by x to the third plus 3 in order to subtract or get rid of the 10x squared. So that wouldn't work. It's only when you have a term that's able to go into the term you're dividing by. So when it comes to this, we're going to multiply by 10x because x times x equals squared, and then the 10 for the coefficient. So we're going to subtract 10x squared, and then you're still going to multiply the 10x by the 3 as well. So then you're also going to subtract 30x, and that's going to get you negative 11x. And then you bring down the 25, so negative 25. Okay. And so then you're just going to do the same thing, and you're going to find a number that can, or a term that can multiply by x to get negative 11x. But since it's a negative, you want to have the kind of, when you multiply a negative by a negative, it gets you a positive. So since you're usually subtracting, if you wrote it like this and then with the negative, that would still be a positive. So it's like you're adding. So when you're trying to find the term to multiply by the x plus 3, you want to make it a negative term. So when you end up subtracting it, it actually is positive. So for this one, we're going to do negative 11. And so you subtract negative 11x. And then you also subtract / add negative 33. So then this cancels out and you're left with positive 8. And then when you're writing your final answer, when it comes to having a remainder, you're just going to write it 10x minus 11. And then you're just going to put 8 over the term that you were dividing by. So x plus 3. And this is your final answer. So we're going to divide again, but this time there is no x squared in between the equation. So when you have a long division equation, you want to write it to where you have every single term going down. So if this was x third, you would have to have a 0x squared to fill in the place, because you can't take away an x squared from or add an x squared to a regular x. So you're going to add a plus or minus, it doesn't really matter, but you're going to have a plus 0x squared, and then you're going to have the rest of your equation. So negative 19x minus 30, and then on the outside, the term you're dividing by. So first we're going to multiply by x squared, and this is going to multiply by x to get minus x to the third. And then you're going to have a minus negative 5x squared, or just plus 5x squared. So then you're going to bring everything down, and now you're going to have 5x squared minus 19x minus 30. So now we're going to multiply by 5x. So 5x, and then this is minus 5x squared, and this is minus negative 25x, and then you just solve that out. So this cancels out, and then you're left with 6x, positive 6x minus 30. For the last one, we're just gonna add 6, and then we're gonna subtract 6x, and then minus negative 30, or just plus 30, and you don't have a remainder. So your answer is x squared plus 5x plus 6. So with the second equation, we're going to be using difference of squares to factor. So for both of these, there is a square root. This one has a square root of 3x squared, and this one has a square root of 5 squared. So when writing your final equation, you're going to take these two square roots, and you're just going to put them together. 3x squared minus 5, and then 3x squared plus 5. And this will be your final equation. So you're taking the square root of the 25 and the square root of the 9x to the 4th, and you're just finding them, and then you're putting these two together in an equation. The reason why one is plus and one is minus is because the 25 has to be negative, and in order to do that, you have to have a plus and a minus. So the next factoring, we're going to factor using greatest common factor, or GCF. So the common factor between all three of these is the 6x squared, because they both have a degree that you can take out squared from. So then on the outside, you just write 6x squared, and then on the inside, it'll just be x squared minus 4x plus 2. Because when you factor these back out, it'll get you this will equal 6x to the 4th. This will equal negative 24 x to the third, and then this will equal your 12x squared. Thank you for watching the factoring and long division with polynomials, and see you in the next video.